This is a video on curvature. The question states, find the curvature k of the curve where s is the arc length parameter. We have r of s is equal to 3/5 s times I minus 2 sine of 2s over 5 times j plus 2 cosine of 2s over 5 times k. And if you watch the last video, then you'll be convinced that this really is parameterized by arc length. And when we have a curve parameterized by arc length, we can find the curvature by using the formula that the curvature k is equal to the magnitude of the derivative of the unit tangent vector. So let's find r prime of s. And what's nice about a curve parameterized by arc length is that the magnitude of r prime of s is always equal to 1. So that means that t of s, which is r prime over its magnitude, is just r prime. So we get r prime of s is equal to the unit tangent vector at s, t of s, which is, I take a derivative, 3/5 s, its derivative is 3/5, and then times I. And for the derivative of 2 sine of 2s over 5, I use a chain rule. We get 2/5 times 2, which is 4/5, and the derivative of the sine is the cosine. We still have 2s over 5 times j. And similarly, I use a chain rule for 2 cosine of 2s over 5, and I get 4/5 sine of 2s over 5 times k, and still have this minus sign from the cosine. So that's r prime of s, or t of s. So now I just find t prime of s, which is another derivative. The derivative of 3/5 I goes away, that's 0. And I use a chain rule again for the derivative of negative 4/5 cosine of 2s over 5. And I get 8/25 sine of 2s over 5 times j. And the derivative of 4/5 sine of 2s over 5 is 8/25 cosine of 2s over 5. And all that's times k. So if we look at this vector-valued function, it has a very nice magnitude, because when I square each of the components, I get a constant times sine squared, and then I add a constant, the same constant, times the cosine squared. And remember, sine squared plus cosine squared is 1, so I just get that constant. So that means that the magnitude of this vector-valued function is this constant in front, 8/25, and it doesn't depend on s at all. So I can conclude that the curvature of the curve for all values of s is the constant 8/25. And I'm done with the problem.